Students, so this is Pratibha Ramgonda. Today we are going to discuss Unit 4, that is MSP 430 Assembly and C Programming. So the contents over here, we are going to just discuss about the instruction set, program development and programs in embedded assembly and C programming. So basically when we are discussing about the instruction set, your MSP 430 has 27 core instruction and additionally it will support 24 emulated instructions. These core instructions, they have their unique opcodes which will be decoded by the CPU, while the emulated ones, they need the assemblers and compilers to generate their mnemonics. So there are three core instruction formats. One is double operand, single operand and program flow control, that is jump. And these instruction sets is orthogonal with your few exceptions, means that all addressing modes will be used with all instructions and registers. First let us see the movement instructions. Now there is the word move, right? Move, which will move your data. So it can address all the memory, either it can be source or destination, including the registers in your CPU and the whole memory map. So example, you can see move.w source comma destination, means you are moving the contents of the source to the destination. Now here .w will denote that the operations can use either bytes or words. Next comes stack operations. Now these instructions, they either push the data onto the stack or pop them off. So example, push.w source to push data onto the stack, and for pop.w destination, pop data of the stack. Now the pop operation, it is emulated using your post increment addressing, whereas your push, they require a special instruction because your pre-decrement addressing will not be available. Next is arithmetic operations with your two operands. So add.w source comma destination, you are adding the two values. Here add c.w source comma destination, means you are adding the two values along with the carry. Now adc.w dst, means it is add carry bit. Sub.w source destination, means you are subtracting the two values. Now sub c.w source comma destination, means you are subtracting along with the borrow, and sbc.w dst, means you are subtracting borrow bit. cmp.w source comma destination, means you are comparing, and based on the comparing result you will set your flags. Now the compare operation is same as your subtraction, only that your bits in the status registers are affected. Okay, so the result will not return back to again your destination. Next is arithmetic instructions with one operand. Those were with two operands. Now the arithmetic operations which will be done by one operand, these are emulated instructions, means the operand will be always destination. Right, now if it is clr.w destination, means you have to clear the destination. dec.w destination, means you have to decrement the destination value. dec.w destination, means you have to do the double decrement of your destination value. inc.w destination, means you have to increment your destination value. In incd.w dst, means double increment. tst.w ds destination, means you have to test, you have to compare that particular value with your 0. Next is decimal arithmetic. Now these are the instructions used when your operands are BCD, means binary coded decimal, instead of your ordinary binary values. Example is dadd.w source to destination, means you have to add, decimal addition has to be taken along with the carry. And dadc.w dst, means here the decimal addition is also taken with carry bit. Next is logical instruction with two operands. So your MSP 430, they have usual and exclusive or XOR instructions, but they do not have any explicit inclusive OR. So the bitwise test operations are identical, but that bit will be only test and it will not change its destination. Example, you can see and.w source destination, means here you are doing bitwise AND operation, your logical AND whatever the truth table you will be considering, the same thing will be here. XOR.W source destination means here we are doing bitwise exclusive OR operation. Bit.w source to destination means bitwise test we are doing, okay, and accordingly the flags will be set. Bis.w source destination means you have to set a particular bit. Then big.w source destination means you have to clear the particular bit. If you want to set the particular bit, you have to use bis.w. If you want to clear a particular bit, you have to use big.w. And if it is a there are more number of bits, so bit.w, where you have to bitwise test will be done in order to set your flags. Then comes the logical instruction with one operands. So there is only one instruction which is known as what? Invert instructions, which is also known as ones complement, where your all zeros will be converted to 1 and 1 will be given to 0. So for that we are using inv.w destination, which will invert your bits. If your bits are having 0, they will be converted into 1. Next is byte manipulation. Now these instructions, they do not need any suffix because their size of the operands will be fixed, like swpb source means you are swapping up your upper and lower bytes, but this is applicable only for your word. Then sxt source means you are extending the sign of your lower byte. Here also it is applicable for your word. Then these swipe byte instructions, that is swpb, they will swap the 2 bytes in a word. And the sign extend instruction, that is sxt, which is used to convert your signed byte into unsigned word. Next is operation of your bits in status register. So there are set of emulated instructions where you will set and clear your 4 lower bits in the status register. Okay, so they can be also masked using your constant generator. Example now, clear C means you are clearing your carry bit. Clear N means you are clearing your negative bit. Clear Z, you are clearing the 0 bit. Set C means you are setting your carry bit. Set N is you are setting your negative bit. Set Z is set 0 bit. DNT, that is disable generable interrupts, and EINT is enable general interrupts. Next are your shift and rotate operations. So there are basically 3 types of shifts. One is logical, arithmetic and rotation. So all are shown over here. These are your left shifts and this is your right shifts. So this is how your bits are going, are shifting towards the left shifts, and here it is shifting towards the right shift. So arithmetic, directly it is shifting. You can see the rotation. Once it has been done, again it is given over here. Once if it's shifting, again it has been brought over here. So these are what explained your shift and rotate instructions. Fine. Next, these logical shift, they will insert zeros for both right and left shifts. Whereas arithmetic shift, they will insert 0 for left shifts, but the most significant bit which will carry the sign will be replicated for your right shift. Whereas rotation, they do not introduce or lose any bits. Matlab, whatever the bits you have given, they will be moving out of one end and it will be entering the register from the other end. Now if it is RLA destination means you are doing arithmetic left shift. If it is RRA source means you are doing arithmetic right shift. If it is RLC destination means you are doing the rotation from left along with the carry. RRC source means you are rotating your right along with the carry. Flow control. Now these are the most common elementary use of call in your subroutine, right, which will begin at your particular label. Like BRSRC means you have to go branch, go back to the called routine. Call source means you are calling your subroutine. Return from your subroutine. At return from your interrupt, and NOP is no operation, right? Next is jump conditional and unconditional. Jump will fit in a single word, right? Now this conditional, we have here this will be having a limit of about 1 KB from your current location, and that jump label is your unconditional jump. Now there are conditional jumps which are decision making instructions, right? So they will test certain bits or combinations in your status register. Now if it is JC label means it will jump only if there is a carry set. JNC label if it will jump when carry is not set. JN label means when you jump if it is negative. JZ label means jump if 0. JNZ label means jump if non-zero. So JGE label is if it will jump only if it is greater or equal. JI1 label will jump if less than it is. Okay. Next is program development. So to program development it consists of editor. Now what is this editor? Editor is defined as what? It is a software which will allow you to enter and modify the program. So the program which is created using this editor will be known as what? Source code. So it consists of commands for your insertion, deletion, modification, etc. Right? Assembler is what? It is a software which will translate assembly language into your machine language. The input to this assembler language will be assembly language source code and output will be relocatable object code. So it will report the program errors during your translation. When it is a compiler, a software which will translate a high level language code into machine, it is called as compiler. And it will also report the program errors during your translation. It will occupy large memory space. It will take longer time to produce results. But the limitations of the compiler are they are low speed and less efficient utilization of your memory. Linker, when you are writing the large programs, it is very difficult that more efficient time will take to divide them into a smaller modules, right? So each module can be individually written, tested and debugged. When all modules are working, they are again linked together to form a large functioning program. So you can say that it is just a software which is used for joining several object files and library functions into one larger executable file. It will also report you the linking errors. Next is standalone simulator, which will simulate the operation of your MCU on your desktop computer without any real hardware. So it will model only the CPU and memory, but it may also include some of the peripherals. Next is embedded emulator or debugger, which will allow the software to run on the MCU on its target system under the control of your debugger. Debugger, what it will do? It will run on the desktop, which is usually will be on the same, on the same front end where your simulator is there. The computer and the MCU, they will communicate through a special interface, that is your JTAG, which we are using for MSP 430. Next is flash programmer. Now this flash programmer, he will download the program into your flash memory on the MCU. IDE, that is integrated development environment. So the editor, compiler and linker, they are usually combined with the help of an integrated development environment. This will keep track for all the files like your source files, headers, linkers, scripts and so on, which is required for a complete project. So the idea which is available for your MSP 430 microcontrollers are, one is IAR embedded workbench kickstart, one more is workbench for your MSP 430, and the third one is code composer essentials. Fine. Next is, there is a simple program shown for you, and here what happens, you have to consider an interfacing of your LED to your MSP 430 and you have to blink it with the writing of C program. So here we can have two cases. One is low and active high LED is connected to port 2 pins of your MSP. The circuits will be shown over here. You can just see for active high and active low. For active high, you are connecting it to your port 2.4 and it has been grounded. The negative of your LED has been grounded, whereas in active, that was in active high, and in active low you can see it is connected to your port 2.3 and the positive is been given to your VCC. Now how is it works? You can see the program. First is you have to include your header file of the device, that is hash include MSP 430. Then this is the wide main. Now WDT CL TL WDT PW XOR or withhold. This is just to stop your watchdog timer, right? Then P to DIR 0x18. This is used to configure your port pins to P2.14 and P2.23 as output pins where your LEDs are connected. Means you are setting your LED with to the output pins. And P2 out is your LED 2, that is P2.4, which is one LED is on, and P2.3 off, which is active low. So this is continuing for your forever. So this is over shown. So you can just see the whatever the explanation I have given here. The first line is what? It is a C which will stop your watchdog timer, which will allow if you won't stop, it will be resetting after every 32 milliseconds. Then the two pins of your port P2 which will drive the LEDs, they will be set to be outputs by writing P2DR. For safety, your ports are always inputs by default when your chip starts up. The LEDs will be illuminated in the desired pattern by writing P2 out. If 0 lights on LED and 1 turns it off because they are active low. There is next program when a button is pushed. So you can just see there is first header file for this, then LED 1 is equated to a bit 3 where your LED is connected just to a port 2.3. Then B1 EQ bit 1 where your button is connected to the port P2.1. Then the next line is used for starting of your 4K flash memory. Then your executions will start. First thing is you have to stop your watchdog timer. After that you have to configure your P2.3 as your output. Okay, so this is your stopping your watchdog. After that you are configuring your 2.3 as output. So there will be a loop. Now you have to test the button. So you are using this bit.b hash b1 at p2 in. Now if it is 0, then you have to skip. Okay, then you have to light the LED if the button is pressed. Then this loop is used to test the button again. So this will continue forever. So this is again your MSP430 will be reset. Fine. So some more programs I will discuss in the video calls. When I will be called, when I will be doing the video call, I will be discussing the programs once again in detail. Thank you, students.